Hello, welcome to Math Mondays. My name is Donnell. I'm your math coach / tutor, and here to discuss ratios today. But before I discuss ratios, I want to make sure I do my YouTube housekeeping. Make sure you like, share, subscribe to the videos, and leave comments of things that you would like to cover. All right, my background is in civil engineering, and I graduated from Wentworth in 2001, and I got about 15 years of engineering experience. So if you guys want to contact me in regards to some personalized Zoom sessions in regards to any type of math, whatever type of journey you're on mathematically, give me a call. Children and adults alike. And you can also catch me at the Roxbury libraries on Thursdays, 3:30 to 5:30 p.m. All right. Okay. This Math Mondays, I wanted to discuss ratios. I left the problem on Instagram and Facebook last week, and I was talking about cutting a wooden dowel that was 150 centimeters. This is a representative of the wooden dowel. I'm going to say 150 centimeters. 150 centimeters. And I said cutting it at a 3:7 ratio. So I'm going to put it here, and I'm going to say 3:7 ratio. All right. So the total length is 150 centimeters. So the question I had was, how, if it's a 3:7 ratio, what's the length of the longer side? So that's the question. What would that length be? All right. Now, in order to think about what a ratio really is, it's a comparison between the two numbers in the ratio. Okay? So I'm going to go back to go forward. If I was to say, if I cut this at a 1-to-1 ratio, we know that I drew this instead of 1-to-1. All right, excuse the line there. I know it's not straight, but I just want to prove a point. If it was 1-to-1, if I said a 1-to-1 ratio, 1-to-1 ratio, and if this was 150, each side would be even with each other. So that would make this, if it was 150 centimeters, each side would be 75. Okay? So that's a 1-to-1. All right, so how do we get the side of how do we get either side? I'm looking for the longer side, but how do we get when it's 3:7? Well, a fraction, we would have to we could turn the ratio into a fraction, but we have to have, what's the whole piece? The whole piece is 150 centimeters, but what's the whole ratio? 3:7 ratio. If you on this, we'll take this example and do it first. 1-to-1 ratio would be the whole piece would be two pieces, right? So it would be 1 + 1 would be 2. So this, if you put 1/2, that's how you get half. Same with this, 1/2. So that way, this would be half, and this would be the other half. Okay? So that's kind of a hint of what we're going to do for the 3:7 ratio. Okay? You learn it like this, you'll never have a problem with ratios again. So no matter how many pieces, it can be 3 pieces, 4 pieces, whatever way we slice this into, we can put it in ratios, but I'm going to turn this ratio into fractions. Ratios are not fractions. They're similar to fractions. Okay, what do we do with the 1-to-1? We added it. So if we add 7 to 3, okay, we get a denominator of 10. So let's add 3 plus 7 would equal 10. So the whole piece is 10. Okay? Now if we put 3 over 10, we'd get the smaller side. Plus 7 over 10, we'd have the longer side. Okay? Then that would equal the whole piece. Remember what we said, the numerator over the denominator, when those are equal, that is equal to 1. Okay, so back to a lesson, relearning the fractions again. I did a video on fractions, but just don't forget the numerator. If this numerator is greater than the denominator, it's more than 1. If it's less than, then it's less than 1. So now, since we know what the denominator is and we know what the fractions are, all we have to do is multiply it times the 150. So remember, if you remember what we said about fractions, if it's 7/10, we could turn that into a decimal. We shouldn't even have to think about it now. We should just automatically say 0.7. So our ratio would be the question mark. I'm going to label this X. Okay, so X is meaning we're looking for that. So I'm going to say X is equal to 0.7, 0.7 times 150. Okay? Don't get scared when you see a variable. That just means we're looking for something. And that just helps us look. So I'm going to stack it. I want to multiply it, but I'm going to stack it. So I wrote it this way, but let's stack it. Let's do the multiplication without a calculator. Let's just, so we get a little practice and not get too rusty. So I'm just going to put 0.7. I'm not going to use the 0. Okay, 7 times 0 is 0. 7 times 5 is 35. 7 times 1 plus 3 is 10. Okay, and we have a decimal here, one place, so we have to move this one place. So the answer is 105. 105. Now we got two ways to do on the other side. We could take 105 away from 150 and get 45. Or we could multiply 3/10 or 0.3 times 150 and we'll still get 45. So we actually got both sides, but the answer was, I'm gonna circle it. Remember, whatever, if they're asking for the longer side, just give them the longer side, 105. Take your time and look over this. If you understand ratios, you're in a good path. All right, this is roughly around, you would learn this in most cases around between the 5th and 6th grade. The latest is the 7th grade. So this is roughly around 6th grade math. All right, so any questions, any comments? Read the comments. I put all the information in how to reach me if you're interested in coaching and tutoring, and also my open hours at the library. All right, so we will see you next week.